For our agenda today, I'm going to spend quite a bit of time on the ITT case study and what we've learned along the way here, going back several years. Why do we need to build a business case, and what some of the industry data is out there that you can start using today to build your own business case. And so I would guess that there's probably not anybody out there that suspects there is not a business case for a process improvement, though there may still be a unbeliever or two. I'm going to make the assumption about my audience, and I'll tell you what that is that I have people listening that have been given responsibility for implementing an effective software process. You may be the process engineer, you may have a quality role, or somebody has designated you as the official change agent. I actually want to speak to other persons who are responsible for the engineered software, the product itself. Or better, the person who has the authority to lead the organization and will be the change agent themselves by using the resources at their disposal to bring about change. To bring the product quality to the next level, free up your creative resources to innovate new product features rather than solving day-to-day problems. So if you're that software engineering manager, the evidence is in. The jury has returned. The question is not whether you should have a software process improvement program. The question is why you're not implementing some of the industry best practices proven to reduce defects, reduce cost, and improve delivered quality. These have been demonstrated in small firms, large firms, hardware developers, IT firms, and so that's some of the things that we will look at today. So the question becomes why we haven't made improvements, and maybe we'll answer a little bit of that. Usually it's because we're too busy. We're too busy usually making a living, too busy getting things done rather than fixing what is broken. And so, but I hope that there's a few kindred spirits out there, someone who wants to use the resources at their disposal to build an agile learning organization of empowered knowledge workers. And that's one of my goals here, that will give you the knowledge that you need. And so I'm on slide 8 here, one of our divisions. And that's, where I've worked, started 20 years ago at ITT, when we first said, well, we need a software organization. And this division was the Federal Systems Division. It became electro-optical. It combined with defense communications, became aerospace communications, and then today is two divisions, the Space Systems Division and the Communication Systems Division. When they split, they had goals to double their sales, and, within 7 years' time, we certainly have doubled and done better in the sales of these two divisions. And so the business that we've been in is spaceborne payloads. Everyone likes to use their TomTom or Garmin or Magellan, but we make the payload that produces that navigational signal that we all rely on. It was that division, what they went through to get to the place where they could produce near-defect software that provides the learning in this presentation. And so you can see there, approximately 170 software engineers were affected by this work, and we'll see that, and we'll go on and say, well, why did this division need to improve? On slide 9. This is one of my most memorable days at work. It was the VP, the boss, called all his engineering managers into a conference room in New Jersey and gave us marching orders. He had just been with an Army general who was trying out our radios, and they didn't work. So they didn't work in the field test. They worked, they passed every requirement, every test worked, but when they got into the field, it didn't meet the general's need. And we needed to change things. And so the boss said we needed to fix the place. That was the words that he gave to us. And he left the room and said, I'm going to come back and I want to hear your plan to how you're going to fix the process here, how you're going to reduce the cycle time by 30% and no defects in the field. They weren't going to be tolerated anymore. And so, there we got to put our collective heads together. But, for us it became urgent For others and for you, it may be that you have a corporate challenge, you may have a customer demand, or just the pressures to compete in, competitive marketplace. And so those were things for us. When I go to slide 10 here, and many of you, I'm sure, have seen this before, and it's almost cliche, but the first time that I read, these 8 steps for change from John Carter, it was enlightening to me. I hadn't seen it before. But the thing that struck me the most was we had gone through these 8 steps, and it was as though the VP was writing the book. And I actually showed this to him after the case and said, how did you know to establish that sense of urgency? How did you know to create that guiding coalition, that team of managers that were going to dedicate themselves not to the day-to-day so much anymore, but to creating a future workable process that not only, influenced the software, which is our topic today, but all of the integrated disciplines at our facility. And his answer to me was telling. He said, it just seemed like the right thing to do. It was his intuition of, being a manager that he gave us that vision of he wanted to work in a world-class engineering firm. And he was tired of benchmarking from others. And that became the motivator for us, and it was when will we know that we're there? And his answer, several years ago to us when we asked that question, when will we know we're there, was when others came to us to benchmark from us. And so today, and I've had opportunity to do this in other places, that vision is fulfilled. And so what are some of the things that we did? On slide 11, we documented our standard process. That was what were we doing today, what did we need to do, how could we get 30% out of that, not having a clue on, how do you get 30% out of it. You got to know what it is today. And so we documented that. And that whole idea of working as integrated teams, you may call it coherent engineering, you may call it integrated product and process development, but it was, seeing manufacturing early, seeing testability early, those kinds of things. We call them structured peer reviews. Now we see in the literature they're called formal inspections or inspections. That's some of the data that we'll look at later. And the idea of milestone reviews were gates, and certain criteria had to be met to move on through that gate. And one of the other things in terms of development methods, it was more model-based, unified modeling languages, or pattern-based development was very helpful to us. This was, once we were doing those things, we saw a clear path to benchmark off of others. And that was that idea of CMM level 3 for software. And that was it was never the VP's goal to meet those benchmarks, but when we presented him the data that were there, then that became important. And then our customer asks for things like CMMI levels, and so the groups that were involved easily moved from software CMM level 3 to CMMI for systems and software, and have been certified and recertified a few times over in that regard. But one of the first things we put together was measuring the rework. And it was that nobody had to tell us to do that. We needed knowledge. And I think that is one of the keys to